This is lesson 62, arithmetic sequences. I know the word looks like arithmetic, but as an adjective, it's arithmetic sequences. And I'm going to work on page 144 and 145. I would encourage you to copy the notes into your notebook. It'll help you remember them. And that way you won't have to look them up. Look up the video when you're ready to do the classwork. And I will also let you use your notes when you get ready to do a quiz. So that will help you quite a bit. So we said it's lesson 62, and it's arithmetic sequences. Now there's a lot of sequences in our number system. We will talk about geometric ones, but there are any kind of sequence that has pattern to it. But we're especially interested in arithmetic in this section, and it is the definition. It is a list of numbers found by adding, and I'm going to underline that because sometimes we want to do it as subtracting, but we'll address that in just a minute. A common difference, and that's the official name of it. And we'll call it D, that's the letter for it, to the previous term. Okay, let's try one. Let's take 5, 8, 11, and then I'm going to put 3 blanks here. Now, in this sequence, especially the whole question is what makes it arithmetic? It's the idea that to get from the first number to the second number to the third number to fourth is you're going to be adding the same number. Call that common difference. So in this case, our common difference, if you don't know what it is, you can, especially if they were fractions or decimals, you can take the first term and take the second term and subtract the first term, which would be 8 minus 5, which would give you the 3. You could do 11 minus 8, which would give you the 3. So that would tell you, and that's why we call it D. It's the common difference, and it's simply the difference between a term and the term before it. So if we add 3, we get 8. Add 3, we get 11. Add 3, we get 14. Add 3, we get 17. And add 3, and we get 20. Now, we want to also refer to the terminology here, and we need to talk about what these terms are. So when we talk about the term, now 5 is the first term, and we call the terms A's, and so we put an A sub 1 because that is my first term. And then so this one would be my A sub 2, that would be my 8, an A sub 3, an A sub 4, an A sub 5, an A sub 6, and so on. We could keep adding the 3 as we keep going. So the terminology there is the idea that the first term is A sub 1, the second term is the 8. And a lot of people get that confused because they think of 8 as being the 8th term. So, and just to mention very quickly the idea of recursive formula, and that's the formula that most of us, that's what we used right here. And that's the idea of, to get this term, I had to add 3 to the previous term. So to get the 7th term, I would have to add 3 to 20. The only problem with this one is that if I want the 100th term out here, I would have to know the 99th term. And so then we have a formula that's called the explicit formula. I know that's kind of a weird name. And this is a formula that you want to learn. And it says A sub n is equal to A sub 1. Now say we had that terminology just then. We have plus n minus 1 in parentheses times D. Now we've already seen that. The D is our common difference. Okay, A sub 1, that's our first term. Now, A sub n is going to be any term except the first one. It could be the 2nd, the 20th, the 58th, whatever. Any term, but not the first. Because you don't want the first term and the first term here. You don't want those to be the same thing. So look at this n, and then that n shows up here, And just like our sixth term was 20, so the a sub n is the term, but the n is simply the number of the term. Number of terms. Number of the term. Let's say it that way. Now, I'll show you where we're going to use that. Okay, I hope you can see that. So, in our problem number 1, we're going to take this sequence and we're going to find the 100th term. Now, as I said a while ago, and it's called recursive formula, and if we use that later, I'll write that word for you. If we did it by recursive, we would have to keep adding 3 here, plus 3, until we got to a sub 100. And I don't personally want to do that. So if I want to find the 100th term, then I can take this information, and it's kind of interesting. You can actually come up with a formula for the problem, but you also can come up with that particular problem. So that particular number. So we're going to say a sub 100. That's the one we want to know. Equals, I'm just following this one right here. I need to know the first term. Oh, we're using that same sequence, so I'll write it out here. 5, 8, 11, and then I'm just going to put dot, 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 and then I'm going to put a sub 1, a sub 2, a sub 3, and I'm going to put a blank for a sub 100. So I've got a sub 100 is equal to the first term, which is the 5, plus, now our n minus 1, and I'm going to actually write it that way, n minus 1 is going to be, we've got 100 terms, see, there's n, 100, and I'm going to write it 100 minus 1. I think you'll get comfortable with it, and you'll say 99 there, but we're going to go ahead and put 100 minus 1 so that you see where that's coming from. That 100 is right here. The 5 was the first term, and then the 100 was that same n. And then we know our d was 3. And it was positive 3, so we're multiplying by 3 here. If you're not used to the number at the end, as we set up the arithmetic, you've got a sub 100 is equal to 5 plus 99 times 3. I'm just doing order of operation. And if you type that on your calculator, you've got, that's going to be 302. So out here, if we added 3 all of these times, we would have, let me scoot that over just a little bit for you. We would have 302 as our 100th term. Let's do a second one. Let's do a sequence. Let's see, I had a good one picked out that I wanted. Let's do 7. Am I on screen? No, of course not. -2, -11, -20, and then if we want to find some more terms, we can. I'll put blank out there, but we're going to find, sometimes they'll say the 100th term. This one actually says what is a sub 34 is what we want to know. We also are going to find the common difference, so we want to know d. We want to know that 34th term, and then we're going to actually come up with a formula for this particular problem. And I'll show you why you would like a formula, especially if you were going to do more than one problem, like if you wanted the 34th term and then maybe the 50th term. So we're going to actually come up with the explicit formula. So it's a formula for this particular problem. So what we're going to do is that we're actually going to put into this formula like we did here, but we're going to actually clean it up as an equation. And I need to do some sliding here, so let me do that for you. Okay, so let's start with our d. So I'm going from 7 to -2, and -2 to -11. And a lot of people want to say d is 9 because you say, well, I'm subtracting 9 to get to that. Well, if you're subtracting 9, because you can do -2 minus 7, but it actually gives you -9. Subtracting 9 is the same thing as adding -9. So -9 plus -2 was the -11. And then add, let's see, I did 7 plus -9, got my -2, -9, let's do plus -9, and that gives me the -11. And then we do plus -9, which gives me the -20. And then -20 plus -9 would give me the -29. Now, obviously, you could just say minus 9 minus 9, but I wanted to show you that it is as an adding problem. That doesn't look very straight. And we want to find a sub 34. So let's go over here. So we've got a sub 34 is equal to, now can you see your formula up here? So we've got a sub 34 is equal to first term. The first term was 7. And then n minus 1, we want 34. See this 34 right here? It's going to be 34 minus 1. And our d was, and I'm going to put that in parentheses, negative 9. Because if you don't, it looks like minus 9. So I've got 7 plus 33 times negative 9. I had to stop and get my calculator. So I'm just going to go ahead and do the whole arithmetic. I'm going to do 7 plus 33 times negative 9. And I get negative 290. Was the 34th term. Now, if I wanted to find the 50th term, if I wanted to find the 80th term, I could put it in and do the arithmetic like this and have to wade through that arithmetic every time, which is not that difficult. But we can actually find a formula that will work for this problem. Now, and a lot of people get this confused and they actually go hand in hand. So, watch what we're going to do. We're wanting a generic formula, and the generic formula means it would work for any n. So I'm going to say a sub n is equal to, so n is going to be my variable in it because it's the thing like if I want a sub 34, 34 would be here. If I wanted a sub 88, then I would put 88 here. So we're going to use that as our variable. So we've got a sub n is equal to the 7, which is going to stay the same in every one of these problems, 7. Plus, now, depending on what the n is, this number will change. So we're going to put n minus 1. You know, if this is 88, that's going to be 87. When this was 34, that was going to be 33. But the d is not going to change. See, that's going to be negative 9. So now we're going to actually just clean that up. Now, order of operations says that we've got to, I'm going to adjust this just a little bit. I feel like I'm about to write off the screen. So, is it straight? So, we need to clean this up. We've got a sub n is equal to 7 plus, I'm just doing order of operations, so, and I'm actually going to go ahead and erase that plus because I've got negative 9. I'm going to distribute it to both of these. So, I've got minus 9n, that's that plus, and then the negative 9 times n, and then plus 9. So, I get a sub n is equal to 16 minus 9n. Now, that's a formula that's going to work for this problem for any term I want. Let me show you. So if we went back and did a sub 34, so especially if you're doing very many terms, it's easier if you get the formula first and then just plug in because see, the 16 and all this work that I did here is already been cleaned up for me. And so all I have to do is 16 minus 9 times 34. See, that's all the arithmetic I have to do. It's going to give me the same thing. So I've got 16 minus 9 times 34, and it gave me my negative 290 again. Now, why do we like this formula? Because what if I want a sub 88? Then I don't have to wade through and put 88 minus 1 and do all that here. I can just do a sub 88 equals 16 minus 9 times 88. So I've got 16 minus 9 times 88. And I got negative 773. What if I just want, and I could have probably counted it out, what if I just want a sub 10? I want the 10th one. A sub 1, 2, 3, 4, 5, and if I was going to go out to a sub 10, look how easy. 16 minus 9 times 10 is 16 minus 90, which is negative 74. So don't get this and these confused because they're actually all tied together. Instead of wading through all of this every time, you can actually just clean this up and then use it for each of the terms. And I think that's what I'm going to do for the next problem.